Hello everyone, today we are going to do last question of the sliding window section in NeetCode. It is the sliding window maximum. Let's get started. Let's read the question first. We have an array of integers and we have to find the maximum number in every window sized k. For example, in this input we have to find the maximum integer in this window, all the windows with size k, and return an array that stores the maximum values. Let's see my solutions. At first I tried to create a priority queue, which is basically a max heap. I added k elements to heap. I find the max. I removed the first element. Then I add one. I go like this. First, this is my heap. I find the max. It's 3. Then I remove this one and edit this one. But when we do that, the complexity becomes too much and it didn't work. So I had to do another solution. Next, I tried a different approach. In this approach, I just added all the elements to the minimum heap, and I set it all the elements of the minimum elements to the minimum value, which not all the elements in the window of this element. For example, in this example, minimum was -3, and the window it's in is this window, this window, and this window. And I set it I think it's these three. I set these 3 windows to -3. I go until the biggest element. Then when I do this approach, at the end all of them are the biggest one, but the problem is it took too much time and it doesn't work well. So to do that I created a custom heap which stores the index and the value of the element, and we compare them according to their value. So it was a bad solution because of the time. Then I thought another solution with the queues. And then first, if the length is 0, it's obvious, we return null. We return an array with length 0. This is our result array, and I iterated until the end of the array. When our list is empty, is not empty, we we remove it to the list, remove an element to the list, of course, and it's not empty and it's not in the current window. For example, now I'm in here. For example, I was in here before. I had these ones on the linked list. When I come here, I have to remove this one. So this line of code does the job. When I go to the next window, it removes the element from the previous window. This one removes the smaller elements because they never can be the biggest element of that window. For example, when I'm in this window, I remove these ones because 5 is in here. So when I continue iterating, there cannot be any case that -3 is maximum in the next windows, because there are 5. There will be 5 in every window when we continue iterating. So to make code faster, I removed smaller elements. I added current elements, of course, when I continue iterating, and I added maximum element to the result array. And that's the best solution I could find. I had this solution as well, but I didn't remember it actually. So I think this one is enough. Let me look. I had a pair, the class. Okay. it takes values and indexes. When we compare what their value, I iterated through the array and I added the index and value of them to our priority queue, and then I basically take the maximum in the window and I set the results with the maximum one. And this is a basic iteration, basic for loop, but I believe this solution is better in runtime, and it's a better approach, I guess. Instead of creating new data structure, I just not data structure, new class. I used existing linked lists, so that's better and easier. That's the best solution I found. Thanks for watching. See you next time.